looking at exponential decay, and we're going to use this by looking at a string. So we're looking at how many times you can cut a 100-centimeter string in half and still be able to measure it. So I don't know, what do you guys think? I think I can cut it in half how many times? Do you think all 15 here, or 3 or 2, or I don't know. So we're talking right here first. Not like how that's situated. I want it to be like this. Here we go. So we're looking. This is weird. Hold on. I want my text box to be where it's supposed to be. It does not like me. All right, maybe I'll draw it in. Okay, so 0 cuts, we've got 100. Sorry that this turns out a little funky. Maybe I'll do it here and just move it. I don't know why my text box doesn't like me. We'll try. Okay, at 1, it's 50 centimeters. Oh, maybe it's because it's too big. Let me know. Okay. Anyways, I'm just going to do it below. At 1, it is 50. At 2, we're going to cut it in half. It's 25. The third time we cut, so we're cutting 25 in half. We get 12.5. At 4, we're going to have 6.25. And I'm going to round some of these. And then at 5, so we're already at 5, we're going to have 3.13, just round in here. At 6, we have 1.57. Again, I'm rounding. At 7, I'm at 0.78. That's not even a whole centimeter at number 7. Not even a whole centimeter. There we go. Maybe I can get this to go in here where I like it. I like it. Okay. At 8, we're at 0.39. At 9, we're at 0.2. 10, we're at 0.1. 11, we have to do 0.05. So that's, less than half a centimeter, right? Like at 12, we're at 0.02. Again, I'm rounding. At 13, we're at 0.01. At 14, it's 0.005. So it's all supposed to be in with 14 right there. And then at 15, I'm at 0.002. Super, super tiny. So we're going to graph this. So at 0, I'm up here at 100. At 1, I'm at 50. At 2, I'm at 25. So that's right between that 20 and that 30. At 3, I'm 12.5. Okay, so 10, it's below the 15. So it's getting a little harder to graph. At 4, I'm at 625. At 5, I'm at 3. 6 is at 1. And I'm just kind of like right here, almost on the line for each of these. None of them are going over. But I'm like just so close to 0 this whole time. You guys see that? I'm never getting over 0. And I think the whole point of this is for you guys to see, this is my messed up a little bit line. It should all go smoothly there. But that what happens to the string is called exponential decay. You can cut it forever because you could even cut, they figured out ways to cut like atoms in half. So you can keep cutting something in half forever, okay? Instead of the values being increased, like we do for exponential growth, each time they are decreasing. Okay? So we know that we can write this whole equation up here as y equals ab to the x. Oop. ab to the x. So that means my equation here is going to be y equals, we started at 100. My b, it's going down by half each time to the x. Okay, so we're going to just look at some more equations. We've done ones like this before. Remember, your a is wherever it's 0. And then if you look, each time we're going down by 5. That's the same thing as timesing by 1/5. So we're going to get y equals 1 times 1/5. To the x. I'm going to type this next one because that's horrible. Remember, if the b value is less than 1, we know it's decay. So they should all be there for that. So we're looking right here at this one. We know it's going to be y equals 10, because that's the a. Now the b, if you look what's happening here, it's also 1/5. All to the x. Okay? Again, we know it is decay because it's less than 1. Now, if we look here at number 3, we've got y equals, my a is right there, number 2. But how much is it going down by? 1/3. It's being divided by 3 or going down by 1/3 each time. Make sure you put that little x at the top there. Okay? Number 4, now number 4 is trying to trick you. Y equals 8. This is increasing, so it's got to be growth, and it's going up by 4 each time. So snuck a little growth problem in there. Okay, so let's just look at one more for graphing here. We're literally just sticking this in. So for this y equals -2, it's just y equals 1 times 1/4 to the -2. Now, when you do something to the -2, remember you've got to flip it. So we're going to end up with y equals 1 times 4. 1 times 4 squared. Okay? 4 times 4 is 16, times 1 is 16. Okay, let's do this next one. Again, remember those negative exponents, we've got to flip them. So we've got y equals 1 times 1/4 to the, -1. So remember, now we have to flip. So this is going to give me y equals 1 times 4 to the 1. And we know anything to the first power is itself, so we just get 4. Remember, when we're doing 0, we get y equals 1 times 1 divided by 4 to the 0 power. Now that is, anything to the 0 power is just itself. So it's just 1. And 1 times 1 is 1. Now these next two are nice positive ones. So we've got y equals 1 times 1/4 to the first power. So we're just going to end up with, yep, that's right, 1/4. And then our next one here, we've got y equals 1 times 1/4 squared. Okay, so 1/4 times 1/4 is 1/16. And then we can just plot these points right here on our graph. When we have -2, we have 16. When we have -1, we have 4. When we have 0, we have 1. When we have 1, we have 1/4. So that's very close to the edge here. And when we have 2, we have 1/16. Again, very close to the x-axis. And we get our like swoosh. Okay? So that is exponential decay.